Objective 2, graphing quadratic functions. So now it's time for you to graph a function if given the actual function. We're going to do this algebraically based off of this function given. Y equals 2x squared plus 4x plus 2. It's quadratic, hopefully again because you recognize the highest power of this function is 2, x squared. Linear, the highest power is 1. Those are the two that we've been talking about so far. So keep in mind, as we do this process, and there's 4 steps. I'm going to break it up step by step and then have you practice each step individually because each step is very important. Some are harder than others. Some are pretty straightforward, but it's still important to know and be able to master each step in order to come up with the final product of drawing one of these graphs. And keep in mind, we talked about this in the last video, but the final product should look something, depending on the function given, but it should be a parabola, like this blue piece right here. That's what we're looking for, that graph right there. Either a smiley face or a frowning face, depending on if it's positive or negative. But it should be a parabola, an arc shape type thing, so that should keep that in mind as you're going about this process. Now, the first thing you should consider, is this positive or negative? If it's positive, the initial a term, then it will be open up. It'll make a smiley face. And so the initial a term, 2, is indeed positive. The number 2 in this function is positive. So I know that the parabola will open up. That should be the first thing you consider every time you look at a function. Is it positive or negative? Meaning, is the first term positive or negative? Then, to step 1, to find the vertex and axis of symmetry, that's what this video is about. The first step always when doing this, no matter what, if you're factoring or if you're trying to draw a graph, is to identify the a, b, and c terms based off of, I'm going to write it up here, remember standard form. Standard form is a, x squared plus b, x plus c, where a, b, and c are all coefficients or numbers. So to find the axis of symmetry in vertex, first step is to identify a. In this case, a is right here, is 2. A lot of times, if there isn't a number before, if it's just something like x squared and not 2x squared, just x squared, then we can assume that a is always 1 if there isn't a number listed there. B is the middle term here, 4, and c is the last term, 2. C is always a constant term. It will never change because there's no variable paired with it. So, again, this is our vertex formula right here. Hopefully you've made note of that somewhere that you can easily access. So x, the x point of the vertex, remember the vertex is a point, an xy plotted point. The x point is found with this formula, negative b divided by 2a. So all we do is take our b and our a and put them in the formula. It's always going to be a negative formula, and depends on, you have to be very careful with your negatives when you're doing this equation. Because let's say your b was negative, but your a was positive. Then as you do the math, you will have 2 negatives in that equation, or that formula, and whenever you're multiplying 2 negatives together, it turns positive. In this case, our b term is positive, and our a term is also positive. So when I get to this point, and I've filled in 2 times 2, when I filled in my a, or my b on top in my numerator, and my a, so again, b on top, 4 becomes b because that's my b, and my a right here, 2 becomes a because that's my a in this case. When I've gotten to this point, I'll count the number of negatives that I see. In this case, I only see 1. So if it's odd, 1 is an odd number. If there was 3 negatives, then I would know, if it's an odd number of negatives, I know my final answer has to be negative. So please keep that in mind. If there was 2 negatives here, like let's say 4, or this 2 I inputted in the parentheses was negative, then there'd be 2 negatives that I would turn to positive, so my final answer would be positive. Please keep that in mind. Now it just becomes doing the math. You can do this in a calculator, put it in just as is if you want to, but it's simple math too. In the denominator, 2 times 2 is 4. 4 divided by 4 is 1, but then there's a negative. I'll show that out a little bit though. 4 over 4, and then 4 divided by 4 is 1. So, -1, that is the x value of my vertex. I'm halfway there. Now, to find the vertex, the vertical value, the y value, so this is technically the x value of my vertex, I'll put that there. To find the y value, I have to plug in my x value, just like we've always been doing. I plug in an input to get out an output. So I plug in my x value of -1 back into the equation for x. This is my original equation, the original quadratic function. So wherever I see x's, they've already laid it out for you. And notice they've put parentheses instead of their x's. This used to be an x, this used to be an x, but now it's going to be -1, my input. -1, -1. And I do that math. And you can enter that into your calculator exactly as is. So, 2 parentheses -1 raised to the 2. Move it over, plus 4 parentheses -1, close the parenthesis, plus 2. So if you make your calculator look exactly like what you see on your paper, you should get the answer of y equals 0. Pause for a second and go ahead and try to enter that on your calculator to make sure you also get 0 to check your work. So, again, x equals -1, this is my y. And so I have found the vertex. That is the entire steps of finding the vertex. The first step is to plug it into my x part of my vertex formula. And then the second step is to plug whatever you get here into the function to get the y. So from here, the vertex, I can now fill in this point down here. Vertex at -1, 0, the x and the y. Now, let's go on to step 2, finding the y-intercept. In order to find the y-intercept, we have to first talk a little bit about what the y-intercept is. So the y-intercept of a parabola is where the graph crosses the x-axis. I'm sorry, that is false. It is where it crosses the y-axis. Makes sense? Y-intercept, y-axis. So where it crosses the y-axis. The y-intercept always has an x value of 0. And for a parabola, the y-intercept will be at the point 0 for the x value, and then here's where the math comes in to make sense of this. It's always going to be the input of 0. So if I input zeros into any function, any quadratic function for the x's, that will make these first two terms 0. 0 plus 0 is 0. So all I'm left with is whatever c is. So 0, c. So for this particular quadratic function in question, I would do y equals 2 times 0 squared plus 4 times 0 plus 2. And 0 squared is 0, 2 times 0 is 0, 4 times 0 is 0, so they both are 0. So I'm left with my c term. This was, remember, this is a, this is b, and this is c. So I'm left with my c term of 2. So my y-intercept is 0, 2. Vertex at -1, 0. And so far, that is all the pieces of information that we have found. Now, keep in mind, be able to answer me this. Why is over here, why is the x value of the y-intercept always going to be 0? Keep that question in mind, and I'm going to come around and ask you guys individually that, or talk about that as a group in class. But why is that? Consider that question. Now, final piece of information that we do know from this is that we can go ahead and fill in the last two pieces. The parabola has a max or min, and the axis of symmetry. The parabola has a max or min, wait for it, the parabola has a max or min, meaning if it opens up, so it's going to make a smiley face, it's going to look something like this, smiley face. That means that it has a minimum point. If it opens up, it always has a minimum. If it opens down, It always has a maximum. And then the axis of symmetry is always, 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 always the x value of our vertex. So the axis of symmetry is -1. So I have filled in all key pieces of information that I've needed in this video. It has a minimum and it opens up. That is step 1 and step 2 of drawing the graph of a quadratic equation.